Hi guys, and welcome to the video on conditional probability. So in this video guys, we're going to learn how to calculate the probability of an event given that another has already occurred. Conditional probability leads to a better understanding of complex decision making. You won't fall for the gambler's fallacy. That's why we're going to learn this. And you'll know you're successful when you can find an event probability using a diagram like a table, a tree diagram, or a Venn diagram. Alright guys, so let's go over what is conditional probability. Conditional probability is a measure of the probability of an event occurring given that another event has already occurred. So we use the following formula to calculate it. P of A given that B, so that is a bar in between the A and the B, and it is pronounced probability of A given that B, given B. But it's A given that B has already occurred. What you're going to do is you're going to take the probability. You're usually going to want to express it as a percent or a decimal. Probability of A and B happening. The little upside down N looking thing is a symbol for intersection, meaning both happening, divided by the probability of B. So an example of this is that 70% of your friends like chocolate ice cream, and 35% like chocolate and like strawberry ice cream. So what percent of those who like chocolate also like strawberry? So the idea here, the probability of A given B would be equal to the probability of both, chocolate and strawberry. So 35% divided by 70%. The 70% is the fact that they are given chocolate, or they like chocolate, and then they all, and that's only the chocolate people. So 70% only like chocolate, and then 35% like chocolate and strawberry. So you're going to take the both on the top over the chocolate only. And then if you divide those, into your calculator, you would type 0.35 divided by 0.70. And if you do that, you will get 50. Oop, that is not a good 5. You will get 50%. 50%. Your calculator will tell you 0.5, which is 50%. So, really quick example of conditional probability. Let's move on to the next. The next concept is called reading a two-way table. Conditional probability can be displayed and read from a table. Within the table, you can calculate the probability of picking from a limited row or column of the table to represent the conditional probability. So, here's a sample two-way table. We have the number of times a student visited tutoring versus them being a full-time or a part-time student. So in our sample, there are 58 total students denoted here at the bottom. Here's our 58. 13 of them are part-time students. 45 are full-time students. A total of 14 students went 4 or more times. 30 students went 2 to 3 times, and 14 went 1 or fewer times. And then you can see the breakdown in the table itself. So not only do the columns add up, but also the rows add up as well. And then if you sum the totals column, that's 58. Or the total column here, that's 58. And if you sum the total row, it is also 58. If you were also to add up the 12, 25, 8, 2, 5, 6, those would also equal 58, the total box. So let's answer some questions about that table. What is the probability that a student who is full-time visits tutoring 2 to 3 times? So the probability that a student who is full-time visits tutoring 2 to 3 times. So we are looking at only full-time students. So we are going to restrict to only full-time students, which means we only have a total of 45 students. We only have a total of 45 students because it requires that a student be full-time. So that is the bottom of our fraction, 45. So the probability of A given B is equal to, the bottom is 45. The bottom here is 45 because they have to be full-time, so all the part-time students don't count. And then we're going to look at 2 to 3 times, so it would be 25 out of 45. 25 out of 45. And then if we type that into our calculator, we are going to get 0.55, which is approximately 55%. It continues 0.55555 repeating, so it's 55%. What is the probability that a student is part-time given that they go to tutoring 4 or more times? So what we have to do is, I'm going to erase this and this. We are only going to examine this row because they have to be, they go to tutoring 4 or more times, and we are asking what is the probability that a student is part-time given that they go to tutoring 4 or more times. So we're restricting it to only 4 or more times. So there are our total, so the probability of A given B. On the bottom, we have 14 students in total that go 4+ times. And on the top, there are 6 students because those are the part-time students. So you have part-time on the top. Oh, excuse me. These students on the top are part-time, and they go 4+ times. So it's the intersection of both. If I go up back to the first problem really quick, the first question, on the top, the 25 was 2 to 3 times. And full-time. So it was 2 to 3, and they were full-time. And then the bottom was just the full-time students in total. So that's where I'm drawing my numbers from. So 6 out of 14, if I divide that, I get 0.43, which is about 40, it's 0.428, which is about 43%. And then what is a probability that a student goes to tutoring 4 or more times? So we're not told any specific subset of students. So we're just going to examine 4 or more times right here. All of the students that go 4 or more times out of the total. So we would just do a quick 14 divided by 58 because there's only one condition to satisfy, and that condition is student goes 4 or more times. So 14 divided by 58 gives us a grand total of, or gives us a decimal of 0.241, which is about 24%. Let me do the approximately 24%. Okay, so using a tree diagram to track outcomes. What we can also do is use to keep track of the outcomes and probabilities. We use what's called a tree diagram. We can create multiple branches to track all the possible outcomes and their probability. As you can see on the diagram, each split is a branch. Each branch has a probability assigned to it, so that's the likelihood of that branch occurring out of 1. You can have a maximum of 1 per branch. So you can see that a heads and a tails each has a probability of 0.5 or 50%, and those are the only 2 branches from your coin flip. And then the outcomes are listed as head and tails, which is the event, the 2 ways the coin can turn up. So we can create multiple branches to track all the possible outcomes and their probability. So, an example of this is a box contains 5 green pencils and 7 yellow pencils. 2 pencils are chosen at random from the box without replacement. What is the probability that they are different colors? So what we're going to do is create a diagram here to track our decisions. So we're going to make our first pick. So this is going to represent our first pick. And there are 2 ways this first pick can turn out. If we draw the tree diagram this way, or we draw the tree diagram this way, you can either get a green pencil, or you can get a yellow pencil. The green has a 5, because there are a total of 12 pencils, has a 5 out of 12 chance of happening. And the yellow has a 7 out of 12 chance of happening. So those are the 2 probabilities that represent our first pick. Then after, okay, we're making our second pick. So we're going to make our second pick. And there are 2 ways that the second pick can turn out. I could draw a green again from here, or I could draw a yellow. And then if I drew a yellow first, there's 2 ways that that could turn out. I could have a green or a yellow. And then I am going to assign each one of these 1, 2, 3, 4 branches a probability. It says 2 pencils are chosen without replacement, so we're not putting them back. So all of these new probabilities are out of 11 because we did not put the pencil back. This is dependent probability. So if I drew a green and didn't put it back, there are now only 4 greens in the box. If I drew a green and did not put it back, there are still 7 yellow in the box. If I drew a yellow first and then didn't put it back, there are still 5 green in the box. And if I draw a yellow first and don't put it back, there are now only 6 in the box. So you can see 4 plus 7 adds up to 11 for the top branch, and 5 plus 6 adds up to 11 on the bottom branch. So now what we're going to do is examine the 4 different outcome branches that we have. And we're going to look for 2 branches, for the branches, that have 2 different colors. So if you go green and then you go to the top green, this branch does not work because those are not 2 different colors. If you go green and then to yellow, that will work. So we are going to include this probability. If you do yellow and then green, that will work, and we will include this probability, which we still have to calculate those branches probabilities, so we're not there yet. And then if you are doing a yellow-yellow, that will not work. So these are dependent events. So if you watched the 6.8 video to calculate dependent probabilities, you need to multiply the events' probabilities by each other. So for the top one, for green to yellow, it will be 5/12 times 7/11. And then for the bottom one, it will be 7/12 times 5/11. So those are how you calculate each branches, okay? So as you move along in the branches, you multiply. So both of the top ones will be 35, because 5 times 7, 35. And then you have 12 times 11, which is 132. And then once you have figured out each branch's probability, these are mutually non-exclusive events. So these are 2 events. These are mutually exclusive events. You can't draw a green yellow and then a yellow green at the same time. It's either one or the other. So you can add these together. So you're going to add these together, and your total probability would be 70 out of 132. And then you can go ahead and approximate that. 70 out of 132 would be about a 53% chance of occurring. Okay, and then quickly, we're going to use how to use a Venn diagram to track probability. If you have a probability, if you have probability in like a Venn diagram, you can use this Venn diagram to place your objects into categories, and you can use the Venn diagram to calculate some conditional probability. So the part in the middle of the Venn diagram is where A intersects B. So that means, in layman's terms, where A and B are both true. Where you have A and B have something in common. So if you take that and then divide it by the probability of the part of B occurring, then you will have the probability of A happening given that B has occurred. So let's take a look at an example. Suppose we have 105 students who are in a group. So there are 105 students in a group. 52 of them took Spanish, so what we're going to do is create a Spanish category. And then 48 of them took biology. Now notice I'm not writing the 52 and 48 in right away because it also says we know 23 took both. So in the middle goes 23, and you need to start with the both calculation here because when you take into account the students who take Spanish and take biology, you have to realize that 52 taking Spanish represents the both and the people who only take Spanish. So this spot over here is the only Spanish people. So if you do 52 minus 23, you get 29. So there are 29 students who only take Spanish. There are 23 students that take both. And then since there are 48 that take biology, that means there are 25 that only take biology, not both. However, if you do 29 plus 23 plus 25, that total is not 105, which means there are a total of 28 students in this spaced out here that take none. They take neither Spanish or biology. Now, it says calculate the probability of selecting a student who is in both, given that they take biology. So it is known that 48 students are enrolled in bio. Probability of P of A given B. 48 students are in bio, but only 23 are in both. So you're going to go ahead and divide 23 by 48, and you get approximately 48%. It's 47.91, which is about 48%. All right, and then we're going to do a Venn diagram that has percentages instead of numbers. 45% of the students in a school have a dog, and 36 have a cat. 30% have a cat, and 18 have a dog and a cat. So draw a Venn diagram and calculate what percent of those who have a dog also have a cat. So we're looking for students who have a dog, then they also have a cat. So what we have is 45. This total circle, we're going to put dog over here, and we're going to put cat over here. So the probability, what we're looking for is the probability of a cat, or probability of, yeah, given that they have a dog. Cat given that they have a dog, excuse me. So 45% have a dog, 18% have a dog and a cat, and 30% have a cat. So we have to put 18% in here. And then since that's the both, we need to take that away from both to get the only categories. So if you do 45 minus 18, you get 27% here. And then the cat would be 12%, 30% minus 18%. And then the next thing that we still have to do is calculate the neither. So if you add up all of these categories, 18, 12 is 30 again, plus 27 is 57%. So 57% means 43% have neither. But now let's answer the question. Calculate what percent of those who have a dog also have a cat. So it's the probability of both, 18%, 0.18, divided by the dogs, which is 0.45%. And then if you go ahead and divide those, 0.18 divided by 0.45, you get 0.4, which is exactly 40%. So 40% of students who have a dog also have a cat. So that's it, guys. In summary, conditional probability is a measure of the probability of an event occurring, given that another event has already occurred, and it can be represented in a variety of different diagrams. Remember that the basic idea that this is the probability of two events occurring, and this is dependent. All of this probability is considered dependent probability. One event occurs and it changes the outcome of another. And then we can track outcomes of conditional probability through various diagrams and then use them to aid us in calculating the probability. And remember that that is tree, table, and Venn diagrams. So that's it, guys. Thanks for watching, and I'll see you in the next video.